Hello, very good afternoon to everyone. We shall start quickly in next 2 minutes. Yes, thank you everyone.
Good afternoon. Good afternoon.
Good afternoon.
Hello.
Hello all, very good afternoon. So before I start, I just wanted to check, am I audible?
Yeah.
Everything is clear.
Thank you so much. So hello all, a very good afternoon, and myself Ekta Dubey on behalf of the Brinalytics team and our partners VCS and Aviva, we welcome you all on a roundtable which is predictive maintenance of your critical assets in cement industry. So before we start the roundtable, there are a few guidelines that I would quickly like to highlight and make you people aware of. Requesting all the attendees to be on mute when the speakers are taking the session. We have a lovely set of speakers today with a moderator. And of course, we would be encouraging a lot of Q&A today in the roundtable. But till then, requesting the attendees to be on mute. There are a few guidelines that we have set for the Q&A. One is you need to raise your hands, unmute yourself, introduce yourself, your company, your designation, and put your question to our thought leaders. So before moving ahead, I would like to introduce our partners, VCS, which offers digital intelligent solutions worldwide. It includes real-time monitoring and analytics, IIoT integration, edge analytics, digital logbook, and predictive analytics using AI ML. VCS takes the responsibility to engage with clients in opportunity assessment, calculating value of improvement, building a business blueprint, delivering required hardware, software, services, and support to ensure that the improvement initiatives is successfully implemented. So to start with today, first I would like to invite Mr. Shrenik Shah, Vice President Sales and Marketing with Value Chain Solutions, who would give some interesting introduction about eCubics and about the session today. So thank you, Shrenik, for being here, and over to you now.
Thank you, Ekta. Thank you for a quick introduction. On behalf of eCubics team and its management, we would like to really thank all our esteemed guests and speakers who have taken our time and joined this roundtable. Ekta has already given a brief about what eCubics and VCS is all about. So I'll just, in a nutshell, give you a synopsis of what services and solutions we offer in the marketplace. We provide enterprise-wide process optimization service that includes business transformation, program management, process study, solution blueprinting, execution involving hardware optimization, middleware, and system integration, and subsequent business support for monitoring and control. We have implemented IT and automation synergies and delivered Industry 4.0 solutions to our global customers across India and Asia Pacific. We work as growth partner and ensure that our partners, customers get the best value of our investment it makes. This is our sixth roundtable that we are hosting, and the premise of hosting these kind of roundtables across different domains is to get industry thought leaders on a single platform and practice business drivers and peer-to-peer sharing of new age technologies in 2022 can enhance customer experience and accelerate business growth. Since we are going to talk about the cement domain today, I will basically touch upon a couple of challenges in the cement domain. After that, my colleague from Aviva, Ramnathan, will definitely deep dive and give more insight on the challenges in the cement domain. And you guys are anyways stalwarts in that particular industry. So definitely Your inputs also in this particular roundtable will make a lot of difference. Uh, Finally, cement obviously is a commodity. It's a capital intensive domain. Raw material and resource labor is definitely a huge challenge in your domain. So these are the three challenges in the cement vertical. There would be multiple challenges, but these are the three which I can foresee. And how in 2022, what are the hot tech investments which organizations are looking forward, which companies are also proposing are increased use of IoT sensors and analytics, data analytics, security. Every customer is interested in improving their customer experience with their customers. Employee engagement platforms, everyone has gone through a lot in the last 2 years. So definitely next thing which organization looking at is how can we improve the employee engagement platforms, machine learning and data science tools. These are some of the aspects which organizations are looking at investing in the near future, whether it's 2022 or 22 to 27. So these are some of my 2 cents on what investments companies are looking at, what are the challenges the cement domain has, and we have people from Aviva who will be talking about what are the different kind of solutions that can help you overcome the challenges which each and every industry and you guys are facing. And with this, I would basically ask Ekta to introduce our speaker for the day. Once again, thank you everyone for joining this particular event.
Thank you so much, Srini. So now, first, I think I would like to invite Mr. Ramanathan B. He is Senior Pre-Sales Consultant with Aviva, and who would be sharing some interesting insights on the subject today, as mentioned by Srini. So, Mr. Ramanathan, thank you for being here and welcome.
Thank you, Ekta. Good evening, all. I am trying to share my screen, but
so now you can. Now you
okay.
can.
All right. Thank you. Yeah. Right. I hope you're able to see my screen.
Yes, Ramanathan, we are able to see
it.
Thank you. Thank you for your confirmation. So good evening, everyone. Thank you for the wonderful opportunity given. So I'm really honored to speak in front of you. So I am a principal pre-sales consultant, been with Aviva for close to 5 years now. I am going to basically talk about predictive maintenance of some of your critical assets in the cement industry, and what we as a as a company Aviva bring to you in the table. Let me start off with the challenges. We had a good good sort of brief introduction by sir. So just to touch upon more details on it. So the mining industry is facing a lot of significant challenges these days. There is a lot of fluctuation in terms of commodity prices. And these cycles, they used to be, close to 15 to 25 years of duration cycles for the past 200 years. But now things are changing rapidly. You have new emerging markets coming up. So this has put in a lot of pressure or significant challenge for the mining companies as the commodity pricing cycles are actually changing every year or even faster. The next challenge would be on the environmental compliances, health and safety regulations. Then you have royalties and taxes that needs to be taken care of. So these are also putting pressures on the mining operators. Raw materials and resources, availabilities in terms of energy and water, they're also becoming more and more expensive, and that is also increasing the overall production costs. So the mining industry is capital intensive, and it is asset intensive, and it requires assets to perform in a reliable way with an optimized usage of maintenance resources and minimal capital investments. The main challenge is the mining company have to now increase their capacity and reduce the operating cost to perform against those challenges. And speaking about it, the increasing visibility to operational data, it becomes a very important factor, or I would say a sort of a promoting factor which will actually help them, increase the ability to react to the breakdowns and the planned downtimes that that come up with the operation, and give them a more efficient handle to basically operate and deal with them as soon as possible. Just to continue on, I will touch upon what Aviva brings to the table. So here, what you see is the portfolio of solution of the complete, Aviva solution stack, and they basically comprises of two, portfolios. So one is your engineering portfolio and the operations, portfolio, and how they actually integrate at the market share level, with the industrial, automation, which is integrated, deep. And actually helps in driving the information analytics layer to both the portfolios. So Aviva's end-to-end portfolio, which is design, operate, and optimize, and you see on the top part of the slide, basically spans the asset and the operations lifecycle. So asset lifecycle basically focuses on the creation and maintenance of the asset, improving its life and the performance. Right? And whereas the operational life cycle basically focuses on the business cycle, or the business perspective, basically the quantity and the quality of the produce of a particular plant. So all this on a foundation which actually helps you to collect, store, contextualize information, comes in at real time from different production sites to distribution channels, is what drives the industrial information layer at the bottom. So today we focus our discussion on the Aviva capabilities in asset performance management solutions, which is going to be our topic for the day. Just to continue, let us have a look at the failure patterns here. What you see on the left side is a sort of a pie chart where it says 18% of the failures that occur in the plants are age-related failures. These can be prevented by using preventive maintenance strategies, but 82% is what is classified as random failure. So why I call it as random? Because where do they start and how long they sustain? What is the rate of degradation of failure? So these are all some of the open questions, or some of the information where we actually lack. So that is why they are called as random failures. So there's no insight into them, and they need a more sophisticated approach of maintenance strategy to basically deal with this, these type of failures. So when you look at the right, that we've depicted, that the APM is actually a journey, which is asset performance management is actually a journey. It is basically a multi-dimensional or multi-pronged approach, which is not based on one single technology, but it is, but it contributes to the comprehensive asset management strategy as such. So there are multiple layers to it, right? So you start off with the bottommost layer, which is the reactive maintenance, right? So which is basically run to failure, and there is need to become proactive with. So when you say run to failure, it is basically you actually let the machine run, and basically once the machine is failed, you basically replace the spare parts of the asset. Then you have what is called as preventive maintenance. So preventive maintenance is basically time-based or calendar-based maintenance, again usage-based. And then you have one layer above, which is called condition-based maintenance. Right, so it is basically based on a rule-based maintenance based on sensor data. You can you can actually formulate condition-based rules to carry out your maintenance strategies. One layer above is your predictive and the prescriptive maintenance. So this is again based on AI and prescriptive analytics to basically drive or predict your asset failures. And then on the top, we have what is called as a risk-based maintenance strategy. So risk-based maintenance is basically a maintenance strategy, which is again defined asset on asset, but it depending on the criticality and the and the importance of its business continuity, a suitable management maintenance strategy is actually deployed. It is basically a combination of all the strategies that you'll actually see in the levels below. Let me cover a little bit more detail as to what we offer from the APM space, right? So Let me start off with the first point on the left, which is asset strategy optimization. Asset strategy optimization becomes important when you actually, when you try to bring in an optimum balance between your under maintenance and over maintenance strategies. And it basically helps in finding a right balance between your cost of non-availability of your equipment, which is your downtime, and the cost of maintenance itself, right? So what asset strategy optimization, or ASO, brings into the table is it offers a risk-based approach to asset reliability. It balances the risk and the cost of safe and reliability operations. So, and this is done basically by conducting a asset criticality risk-based assessment with the RCM, or a reliability center maintenance approach, and then identifying the right maintenance approach for different types of assets and their usages. The second point, which is on the asset analytics. So, this also helps in reducing your downtime. It actually works in combination with your predictive and the prescriptive analytics. And this is a topic which we'll actually discuss in a little bit more detail in the session now. The next part, which is the asset maintenance, it is again the so this is again based on your RCM procedures, basically, your creation of your work permit solutions, your mobile maintenance, your enterprise asset management. So all these, framework or infrastructure is actually provided by the asset maintenance solutions. So, again, based on our experience with, similar customers, so we can, and our, previous project experience, so we can actually bring in a sort of benefit in terms of overall, OpEx, savings of ranging from 10 to 20%, a reduction of downtime around 25%, and also 30%, close to around 30% of maintenance cost savings by enforcing or implementing these APM solutions. Now let me cover more detail as to what Aviva Predictive Analytics as a methodology means to us and what is being offered to the industry. So this again works on an advanced pattern recognition algorithm, right? So and this algorithm, what it actually does is basically learns and monitors the behavior of equipment at different loading, ambient conditions, and operating conditions, right? So once the pattern recognition is actually done and the data pattern is actually and a predictive data model is actually built. So this will actually help you in providing early warnings or indications of equipment problems and failures, right? So predictive asset analytics is not based on any first principle modeling. So here we don't require any OEM specific information in this case, but yes, we would require the operational data from the process historians to basically build the data predictive model. And it is asset agnostic and vendor agnostic, right? So it basically usually uses and learns the sensor data which is collected from the plant historians, and it actually builds a signature of that particular asset at different conditions, be it loading conditions, ambient conditions, or operating conditions. And what it basically does is it then compares this operational signature, right, which is considered to be the normal operating condition of the asset, with what is being measured at the plant at real time. And when there is an anomaly detected between these two asset signatures, that actually creates a sort of an alert which says this particular asset is, so there is an abnormal behavior in the asset, and it gives a sort of a guidance to the operator to basically carry out the maintenance and visually inspect. So we for the cement, so we do cover certain assets which are very relevant for the cement. So it could be pulverizers. We could actually implement predictive models for the crushers. It could be for the kiln. It could be fans, blowers, pumps, gearbox, motors, turbines, and generators. So we can cover these some of these assets are relevant for the cement industry through this solution. And it not only does the prediction, it also provides you diagnostic capabilities, right? So that you can actually drill into the data and basically identify root causes for that deviation, and provide and further it also provides prescriptive solutions to basically counter the problem. Right. So a little bit more detail. So what I see, what I'm showing you here is, if you look at the left side, this will give you a more idea, a little bit more detailed idea as to where, how the predictive asset monitoring actually works. The predictive asset solution is basically a multi-dimensional model, right? So it basically takes signals from different sensors for a specific model and considers those relationships with that signal and the other signals in a three-dimensional space. But for simplicity, what I'm actually showing you is a single variable. So which is, in this case, it's a temperature variable with respect to time, right? So this is the black line that you see here. So with this is the temperature, how the temperature actually varies over time. And the red dot that you see here is actually the DCS high alarm, right? Which is actually configured in the DCS. I'll just go shift your focus to the right side of the picture, right? So here, I mentioned in my previous slide that we actually build a predictive model, right? So which is actually shown by the blue color trend line. And what actually happens is, if there is a slight deviation between the values of the transmitter, in this case it's a temperature transmitter, and the predicted values, it immediately creates a sort of an alert. And you can see that this particular alert is much lower than the DCS alarms, right? So this is typically the space where the predictive monitoring solution actually operates, right? So what it basically does is, it basically gives you a lot of lead time in terms of immediately detecting the abnormality in the asset. And this can actually be converted into a good amount of lead time for planning your maintenance. It could be your spare parts management, or basically taking your shutdown a little bit early, or also delaying your shutdown, because you are continuously monitoring how the asset is actually deteriorating over time, or the abnormality is actually building over time, and that gives you that sort of a lead time for the from the solution as an output, to basically monitor your assets and see if you can run that asset at a lower loading condition till you reach your next designated shutdown. It is so the complete package as such. You have a lot of other functionalities as well, which I have actually listed in the as a part of the solution in this slide. So the one main thing is the main important thing is the large scale deployment of the solution, right? So because we are not talking about a single asset here, but we are actually talking about how we can basically monitor assets at an enterprise level. So the scalability of the solution is very important, and our solution is able to do the scalability, perform on a scalable terms, to basically extend the monitoring solution to a enterprise level, right? So in addition to that, we also have model templates, alert management, remaining useful life. So these are all different features. Probably will not be able to discuss everything in this particular session, but we can actually deep dive when we have more detailed discussions, right? So case management, alert management. So these are all very important when the solution is actually scaled across an enterprise level. The later part of the presentation, what I'm trying to bring in is a couple of case study references. So Votorantum is our recent references in the predictive monitoring space. So this is basically a Brazil-based company, so which actually produces about 53 million tons of cement every year, And there are and the APM, the predictive monitoring solution is actually being deployed across 16 sites, and this has actually given them a benefit of Brazilian dollars of 23 million. In the first year of deployment itself. And this has also converted into a 10% reduction in the recurring maintenance cost, 6% improvement of reliability across the 16 plants where the solution has been applied, and also a 10% reduction of unplanned maintenance costs, right, through the successful deployment of the solution. So the next, just to continue, or just to indicate, how the solution has actually worked. So I've given an example of the ball mill, anomaly, which the solution has actually detected. So here, what you see here is, this is the normal trend of the temperature bearing. The temperature sensor of the ball bearing, which is trended over time, and because of a contaminated oil, you can see there is an temperature increase, which is actually with the solution is actually detected. So the red line that you see is the actual trend, and the blue line is your predicted model. Right. So when there is a difference between the blue lines and the red lines, it immediately there was a alarm which was triggered, and this resulted in a local inspection of the asset. And in this case, it was a contaminated oil which was detected, and the oil replacement which was actually done proactively. This was able to save the bearing, which was again a huge savings in terms of avoiding the bearing replacement as such. So the next case is the Tata Power case. Again, this is again in India a very prestigious case. So here we have actually built what is called as an ADOR center, which is an advanced center for diagnostics and reliability center. So here we have deployed predicted models for across 3 phases, right, to cover about 6 plants of them of Tata Power. And the implementation actually started in 2015 onwards, and it was completed in around 2 years across the 3 phases. So we are basically monitoring 6 gigawatts of integrated power assets, and we have deployed more than 1,100 predictive models. Right, so it could be, this is again the form of mechanical performance and transient models. So we were able to save about $700,000 through some 200 early warnings and smart catches, which were detected after the solution was built and deployed over 2 years. So this was the last slide. That brings me to the end of the presentation. So if there are any questions or comments, you can reach me, and we can we'll try to address those. Ekta, back to you. So I am done with the presentation from myself.
Thank you, Mr. Ramanathan, for interesting insights. So before we move on to the another test, I would like to understand if we have any questions for him. We would love to take it. Or as I've mentioned in the chat box, you can mention your questions there, and we would love to take it from there. So any questions, you can simply put it to
yeah, I do have one.
Please, sir, please.
Yeah, Ramanathan, I just wanted to understand what type of protection, what type of predictive maintenance your system can offer for critical asset like transformers. The main incoming transformer, 25 MVA, 20 MVA transformer, which will be installed in a cement plant of around about 1 million ton capacity or something of that sort.
So transformers, see, we have got some use cases around transformers. The problem is, there is the behavior which we actually see within the transformer, right? So in terms of your pressure difference, or in terms of the temperature rise, happens very abruptly, right? So that becomes a sort of a challenge for the predictive models. right? So that being said, we don't have a lot of cases around the transformers. Just to give you a straight answer to you.
But,
right? But
normally, in a cement plant, the transformers are the one which has been least cared, and it results in a failure. It will result in the entire cement industry to be closed.
That's correct. So that's correct. But see, again, the problem is, we are not looking at a gradual failure of the asset, right? In terms of a transformer, because the abnormality happens. That's what we have observed. The abnormality actually happens very abruptly, right? So
no. Actually, if you go through that life cycle of a transformer, naturally the transformer doesn't fail immediately, like the case of a motor, bearing, whatever be the things, and it gradually decomposes actually, because it has got paper inside the transformer, and the oil has got gaskets leaks, then oxygen, atmospheric air enter into the system. Then because of the heat and the component O2 in the air, it converts it into H2O, water, then paper gets degraded. So DGA is there. So I just wanted to know whether you are having some inputs from DGA which will be fed into your system. Okay. Now the second thing is regarding the MV panel. What all predictive maintenance you carry out with your system for this this MV panel, which gives the power to the entire cement plant? What all?
So the solution itself is more, I would say, is more adaptable for the rotating machinery, right? So transformers and again panels are something that we don't deal with, right? So it is mainly
thermal imaging, nothing ultrasound units, something of that sort. You cannot club it along.
We don't have a solution, sir. We don't have a solution for that. It is basically for the rotating.
So you are basically covering up all the rotating equipments.
Exactly.
Motor. Exactly. So for motor, you do have anything PD sensors, something of that sort, which is reporting to your AI, which further give us input, like the motor winding is going to fail, something of that sort.
Exactly.
You are doing that?
So we don't provide the sensors. So what we actually do is we first understand what kind of sensorization is in the plant, and we can get started with building the models. And then we can, basically mutually work and see if by adding on more sensors, because more the data, more the quality of the data, the better will be the quality of the predictive models. Right? So we are not saying that we should have, n number of sensors to actually get started with the predictive model. We can start with whatever is there in the plant as a landscape.
Okay, that means the sensors which are presently connected to my DCS, you will take the input from there itself.
Exactly. That's right, sir. You're understanding.
Okay. Because basically, I was looking into that one, like for a motor. There are PD, there are ultrasound sensors are available now, which will be feeding into your AI, and you work on that one, because based on a lot of other plants data you may be having, based on that you can give us the input. Okay, understood now. Okay.
Yes.
Any other questions anyone has?
Yes. So we have Mr. Lokendra Singh Chauhan raising his hand. So please put your question.
Yeah, my question is to Mr. Ramanathan. You have shown in your presentation that 30% of the maintenance cost is decreased in other plants. You have worked in the water and team also. So my question is, to save this 30% cost, suppose if we take a plant of 9,000 TPD. So I would like to know what is the ROI time for the investment which we are going to make in the predictive maintenance.
It will be very difficult for me to actually comment on anything, sir, but we'll have to look at your data and understand. And we can actually work out a ROI calculation. So it will be, at the top of my head, it will be very difficult for me to comment on any ROIs.
Since you have worked in the water and team, that's why I was asking this question.
Okay. But we can understand your plant capacity and your previous maintenance breakdown histories and data like that, and actually bring up a ROI calculation.
Let us talk about the new line. If some new plant is coming up and they want to install this predictive maintenance instrument right from the start only. So is it possible for you to comment on that?
So comment in the sense, are you asking for a specific ROI figure?
Yes.
I
A
think
tentative time figure.
Ramnathan, I think Shrenik this side. I think what you can basically look at it is not the tentative figure, but at least the parameters on which you can calculate the ROI. Probably if you have some parameters that, okay, 1, 2, 3, 4, 5, 6, these are the parameters on which you can calculate the ROI. Obviously, nobody on this call can give you an exact ROI figure, but under what parameters, what are the tangible and intangible parameters on which you can look at getting the ROI?
Okay, so one is the automation level of the plan. So we will have to look at, whether you have a process historian, from which the AI solution can actually, communicate with. And if you're looking at a certain critical asset, what is the sensorization around that, assets? So these are all some of the inputs that we look at. And then we would require at least 6 months of, operational data to basically start building our, AI model. And then we can we can basically backplay that predictive model, and if over that 6 months of operation, if there is a failure that the plant has actually that particular asset has actually encountered, so we can backplay the predictive model and see whether the predictive model is actually has been able to predict that particular failure some days or some weeks in advance. So that is sort of a benefit study that we actually do. And that can also be converted in terms of the ROI. Once we know, what is the breakdown cost, if the particular asset actually fails, how that is actually equated to a X amount of, production loss. Or if you're going to replace the complete asset, that is going to equate to your spare parts, spare part replacement costs and things like that. So we will have to work out that sort of a ROI calculation. That can be.
Thank you. We have one last question for the session, and then, of course, we'll move to the roundtable. So this is from Sohaib Hussain. Sohaib, do you want to ask yourself, or can I read out your question?
No, I will ask myself. Thank you. My question is for Ramanathan sir. I just need to confirm, you talked about the prediction thing. So you are using the prediction, giving the prediction by ML-based model or statistical models?
This is ML based, sir. So we have our own pattern recognition algorithm, which is patented. So and it is purely ML based.
Okay, is it some specified ML based? Any is model ML model?
We use an algorithm called as optics, that is actually ML based. Okay. So I can give you more details on the algorithm. So we can have a more detailed discussion.
And you also talked about that rotating machines. So when you say about the rotating machine, do you use any high frequency data in that or any analysis part?
Yeah, so we can also interface with the CBM. So if they, most of the rotating machinery, they will have to take into account the condition monitoring system also, right? So so all the high frequency vibration data can also be built within the pattern recognition. But the predictive model as such, it does not. It need not actually predict at such a high frequency, right? So because we are actually looking at a gradual degradation of the performance of the set.
So when we look into the high frequency, that with that same thing, a predictive can be done with high frequency.
Yes, that can be done.
Okay, thank you. And whether you are giving that RUL with every equipment remaining useful life in your model?
Yes. So that is one of the more recent features that we have actually gotten in terms of development of the solution. So that gives you an idea as to how long the equipment can actually be run at a particular condition till it actually achieves till it goes to complete failure. So that helps you in basically planning your maintenance strategies much more. That is the whole idea.
Okay, sure. Thank you.
Just to add what Ramanathan said, I think when we talk about Aviva and the kind of solutions, predominantly the company is all about software application and everything. So the complete application is what they drive, and all the data from the hardware and everything is all pulled from that particular thing onto the Viva system, and then the analysis or predictive analysis and all that stuff is all taken care. So the idea about this particular thing is they basically pull the data from the respective hardware, and then they do the analysis and everything, and they have their own inbuilt algorithms through which they basically come up with the calculation, and they throw up the numbers to it. So Ramanathan, if you want to add anything, this is what at a broader level I have just put across.
Your methodology and understanding is correct, sir. So that's right.
Thank you.
Thank you. Okay, so Shrenik, I think we should be moving to the panel now, the roundtable.
Yep, absolutely.
Great. So now moving to our interesting roundtable discussion, which is on navigating the benefits of predictive maintenance strategy in cement manufacturing. The key focus areas that we would like to explore with the thought leaders are effective implementation of predictive maintenance in cement manufacturing, real-time monitoring conditions. Real-time condition monitoring helps in driving efficiency and improving the competitive advantage, and the features of predictive maintenance in the cement plants. So I'm happy to introduce, today we have a wonderful set of speakers. We have Mr. Lakshmi Nivas Sharma, General Manager Operation, Dangote Industries Limited. We have Mr. Manoj Bari, Head Technical Cell with JSW Cement. Mr. Vikas Bhardwaj, Head Electrical and Instrumentation, Shri Jharkhand Cement Plant. Mr. Gaurav Pratap, Head HOD Mechanical with JK Cement. Mr. Vinay Chandran Shinoy, Head of Electrical and Instrumentation with JSW Cement. Mr. Mukesh Sinha, Technical Head with Dalmia Bharat Group. Mr. Surat Mukherjee, Senior Vice President, ACC Limited. Mr. Lokendra Singh Chauhan, HOD Dispatches, Star Cement Limited at Meghalaya Unit. Mr. K.M. Moshafikul Alam, Chief Engineer and Head of Plant with Basundhara Cement, a unit of Basundhara Group, right from Bangladesh. And Mr. Jatin Chandra, Vice President with Hira Group. And of course, we have a moderation from Shrenik, who will be taking this ahead. So thank you for wonderful panelists for joining us today. I shall be adding in the spotlight, and the discussion starts. So over to you, Shrenik. Thank you so much.
Yeah. So I think we'll start with what it has already put across as a question, and I think we can basically, I'll just basically run through the focus areas. Obviously, when the panel discussion is obviously the effective implementation of predictive maintenance in the cement manufacturing. So I would basically invite Mr. Vinay, if you can basically throw some light on how have you done this particular thing in your organization and what are the benefits that you've gone across. We can have Ramanathan also in the spotlight. So if there are anything, he can also add value onto the particular thing.
I will. I'm just adding everyone.
Yeah.
So I'll take up now. Actually, this predictive maintenance, what we in JSW Cement and the other cement plants where I've worked, we have implemented is that the critical asset, which is like the transformers, which are the main heart of the cement plant, we try to have the DGA done on a yearly basis. And any variation from which is abnormality, which we identify, it's not through AI, it's just through the experience, which we have got some certain ratios, which are baselines for us. So we try to go use that base data, and if there is any variation, we can easily identify. Previously, what we were doing is that we used to do oil filtration every year. It's not required because basically once you heat up the oil, it disintegrates into a C and H component. Then if it gets any oxygen from the atmosphere, it will be converted into H2O and it will degrade the oil. So that is one part which we have taken up. And we, as such, the ratios have given us a very good life. And normally the life of a transformer is more than 18 to 20 years without any problem. Only through oil filtration, we can maintain that. But if there is any problem of leakages into the system or from the outside atmosphere entry, air entry into the transformer tank, it results in failure. So that one part we have done that, and we are almost all the plants where I have worked at, we have put up this system, DGA and other things, and it is working perfectly fine. Second thing is the MV panel and the LV panel. In those also, we used to have normally During preventive maintenance, we used to measure the contact resistance and other things. But if you use an ultrasonic sensors, which detect low speaking, very high frequency signal like chattering and other things which is happening inside the breaker, the contacts, it will be easily identified along with thermal imaging. Thermal imaging is also very much important for that electrical panel actually, because it gives you an input that there is something hotspot is being developed, and it doesn't get deteriorated immediately. It gradually decreases the life and then it goes into failure. So we can opt thermal imaging and ultrasound sensors that gives you an input. If you have gone through this motors, the bearing failures happens in 4 stages: stage 1, 2, 3 and 4. So if you go through that one, in the stage 1 it will be in ultra, it will be in around about 120 kilohertz. That frequency, the signal will be generated. Then it gets deteriorated and it moves into the audible level. So similar is the way for our MV panel, LV panel, all those things. So, and one more input which we have used is motor current signature analysis. Motor current signature analysis, that's a wonderful item, wonderful this one. We can do it on online. And we have used it and we are reaping the benefits also, because we know in how many months the motor will get deteriorated, how many months we can plan. We can keep the motor over there at the site, wait for the shutdown. If not, shutdown is not available, we can plan and execute the jobs with other departments, mechanical, electrical, even motor current signature analysis can give input to the mechanical department also. So as a technical person, you will be helping out your colleagues who are on different equipment like gearbox, whatever be the things, because all the signals gets reflected into the motor current signature. So it will be wonderful. So this is one thing which I wanted to add up: thermal imaging, motor current signature analysis and DGA. If you do it, your system will be much more reliable. You can go about 330, 340 days, 360 out of 365. That we can get it done. Only that much, sir.
Thank you. Thank you, Mr. Vinay. Anyone from the panelists would like to have a question addressed to Mr. Vinay, or anyone would like to add your inputs on that particular question that I basically rolled out? Please feel free to add your inputs on this particular stuff. Anyone? Mr. Lukender, you want to add something? Mr. Mukherjee, Mr. Bradwaj? It's an open discussion that we would like to have, and we would like to understand from every one of you that how you are basically managing this particular stuff, and how effective implementation of predictive maintenance is helping you in your organization. Any input we can throw to the industry people that would really help each other.
I would like to add one point on this, that the thermal imaging and is a very important part, as Mr. Vinay sir told that. But we are also going for the online monitoring of the VRM, all VRM gearboxes. All various sensors are installed, and it gives online conditioning monitoring for all VRM gas, which is monitored on daily basis, even hourly basis also. Based on that predictions, we used to plan our shutdown. We used to plan our maintenance of major gearboxes. It has prevented many our breakdowns also. Our major aim for this any type of technology adoption is for zero downtime, which is the most aim for all of us. So it is very important that online conditioning monitoring is going to be implemented. It is already in process. We have a few sensors also which are not wireless, but have a good battery backup, so that the wiring problem is also nowadays are going to eliminate. As we are moving towards the technology advancement, and we are going to implement having the 5G technology in our country very soon. So this will also help us to have a real-time data for major equipments, And presently, I have visited many Siemens factories in which they are giving the vibration sensors for the gearboxes, which are very critical and which are not installed, which are installed at remote locations like Prater top elevator. It is almost 150 meters above the ground level. So that condition should also come to the maintenance engineer, and it also helps the, as sir told, it also helps the other departments also.
True.
Having a better understanding of all things. So as we are going towards the AI, as you told also, that it is future of our industry, that we are having going towards AI. And one of the quote I have read in our cement magazine, that future cement industry will have no employee in the field. One watchman with dog will be there. The watchman is not for taking care of equipment. He will be there for the taking care of the dog, and dog will ensure that no one touches the machine. So, so because of AI, we are going to have such kind of reliable maintenance practices in our industry future. And we are all industries in India and cement industries are adopting this technology very fastly. So, and the cost cutting is one of the major factor which we have. ROI is one of the factor, but if we get long-term benefit also, then we can go for that. Everywhere ROI is not, as per my view, everywhere ROI is not thinkable. We have to also think of our business continuity also. That's all from my side.
Okay, thank you. Mr. Vikas, you had something, I think.
Yes. This is Vikas. I'm from Sri Cement in Jharkhand unit. And I would just like to ask you people one thing. Actually, what I see usually is our plant is not actually upgraded to the level that we could just switch off into IoT and AI. We don't have any instruments which are also compatible. So what are the switching costs involved actually? So what will be the switching cost that needs to be taken, because this will be a entry barrier for many units. I think okay, if somebody is very good and they are up to date, okay, that's very good. But for a plant like mine, we need to have a switching cost which can be an entry barrier, and there will be integration which will be required from your side. So what will be the actual cost, and what will be the we need to change anything in our existing systems? We already have some historical database systems. We know we are having this current signature, we are doing gearbox monitoring, we are doing. But is that enough for you people to integrate all the AI that you have? And do you have the instrumentation capability, or you can supply these instruments? And what will be the switching cost? That will be a point of concern for a lot of people, maybe.
Ramanathan, you would like to take that? I'll just basically add on the hardware front, Mr. Vikas. Yes, there are a lot of solutions which have become available on the hardware front. As an organization, as eCubix, we've also deployed a lot of IoT devices in pharma domain. We have almost deployed vibration sensor and temperature sensors in a pharma domain, where we're collecting data and everything. Almost like 500 plus sensor devices have been deployed out over there, and the entire data has been pushed in the historian, which has been deployed by Aviva team. And based on that, the customer basically does the data lake layer kind of stuff which has been created, which is an L2 layer in the system, and the entire predictive analysis and everything are basically done on that. So yes, as an organization, we are a solution provider. So we just provide just not the application or the solution. We also provide the entire hardware, where we can basically do an end-to-end implementation. Obviously, there is a process behind that we need to come over and do a site study, understand the equipments that are there from an Aviva point of view, also from an application point of view. Also, what are the traditional system, the MES system, or the DCS system that you have? What are the kind of OPC connectors which are available with you? Whether they are compatible with the systems and all that stuff, and then the integration part of it, and then ensuring that the data is actually coming to the last mile, which is end user like you, whether you can take certain strategic decisions based on the data that has been received. So yes, these are available. The cost varies from sensor to sensor. As I said, there are multiple sensors and there are multiple OEMs who are offering these kind of solutions. And we as solution integrators, we basically work with these multiple OEMs and ensure that we have an end-to-end integrated solution which is given to our customers. Ranathan, you want to add anything on the Aviva front?
No, very nicely summarized, sir. So, you know, the beauty of the solution is we can actually get started with what you have. So we never, you know, recommend that we will have to, you know, completely change or basically upgrade your sensors of the assets to basically, you know, bring in data into our solution. So we can get started with what we have. But as you see, you know, as we start building the predictive model, we can actually bring in more sensor data to basically improve the quality of the model. So that is something that we can, you know, both of us actually work together to when the model gets progressed and when you see the predictions coming in. So you will actually, you know, also we both can actually appreciate the value of the solution, and you know, that will in turn, bring in more sensor data into the solution, and we can, you know, do a sort of a mutual agreement and progress forward. But the other points is the basic pointers of, you know, how you actually, you know, store the data in terms of, you know, how we can actually, you know, connect to the historian. So OPC connectivity is again, you know, one of the fundamental things. So, you know, if these are all in place, so we can surely, you know, move forward on this.
Mr. Vikas, just to add what Mr. Ramanathan also said is, whatever are your erstwhile systems, we do not say that you obsolete those particular things. We use those systems. We ensure that those systems are being utilized in the right way and get the data onto the system or on the Aviva platform. So that's how we basically do that. And as Mr. Vinay rightly said, the other speaker also rightly said, it's ROI versus value. Because every time it cannot be an ROI, there has to be a value also which has to be brought on the table, because I understand everyone is on a cost-cutting sphere. Everyone needs to ensure that their capex and opex are managed in a way that you don't overspend it. But at the end of the day, it's basically you have to decide what is the value that you're getting out of the entire solution. Whether you can actually predict your business and strategize your business for the next 1 year, looking at the kind of investments that you do. Because as you everyone knows in the industry also knows, there are multiple solution providers. One solution might be costing you $1 million, one might costing you $100,000. Everyone gives the same kind of stuff, but finally at the end of the day, what is the value that you get on the table, and what is the end result? The end result is the business should be able to grow. You should have a faster advantage to go to market. That's the whole idea. Everyone over here invests in technology to ensure that you have a faster go to market in the competition. That because everyone knows that the first 6 months is a break even. After 6 months, someone will go to replicate your strategy or the solutions that are there and then get into the market. So it's very important that you define your strategy, define the right kind of solutions, the solution mix, and the right kind of partner to ensure that you have a added advantage to get into the market.
And I think the most, if I can add a few lines, being a non-technical person, I think what I have seen is that I think the mindset change for all of us is the most important thing. You know, when we will start trusting machines more than our instincts, because as of now, still we go more by our instinct. So we have this habit of the car will show that a maintenance is due and you should take a maintenance within the next 100 miles. But we'll keep on doing it because it's not our time, or it's not the most favorable time of the season, or I want to go into, you know, some long drive and stuff like that. So when sensor starts telling us what to do, it is important that we go by that instead of, you know, deferring the stuff for a long period of time and then putting human judgment on top of it. You know, that is where, you know, because this being a very, very old, experienced industry, which maybe thankfully has really not evolved so much technologically as compared to many other industries. You know, other industries have literally turned on its head, but in this industry, we have 70, 80-year-old units also still giving production and giving profits to the organization. So with that mindset, we collectively need to start not only investing without looking at ROI, but also trust the machine and trust the output which comes, and then see how that can bring down, you know, abrupt downtime or breakdowns and stuff like that. So I think it's a journey. Many other industries have started much earlier than us, maybe. But I think it's never late to start. And once we start that journey, as that guard and dog story has been told, so we have to move towards that.
Absolutely.
Yeah,
Mr.
Mukesh.
Mr. Sinha, you had something to say.
Yeah.
Yeah, thank you, Dada. Thank you, Surat Saab. He's my friend only. So again, namaskar to all. See, this side, Mukesh Sena from Dalmia. What I'm speaking with my personal capacity here. See, as far as the critical asset is concerned, let me start and give a very brief 30-second key. Land and mines is also a critical asset for cement industry. So if we are predictive on land data or land security or land use or the safeguarding the land asset, and then knowing the mines in the best of the best manner is also very essential for being profitable always. All my journey in cement, whether it is a 50-year journey or 100-year journey, is depending how good our asset, particularly our the raw material management, which we say from mines to logistic, it fully depends upon how much good quality and better million ton capacity we are having in our kitty. So as far as predictive model for this land and mines is concerned, there are many software available nowadays, but how much we are using is also a concern for each and everyone, because somebody is not knowing because of technical people front, there are issues, and they don't want to invest much. But yes, technology are there, and now we have to go extra mile in understanding those technology to reap the benefit of the predictive aspect of this management. Now, going forward, we are going to an auction regime when the whole critical assets of mines is going to play a very vital role. Now, we from cement industry know how coal is playing very important role, and the whole profitability is at very in a sword this thing point. Now, when we talk next 5 years down the line, the limestone cost is going to play much differently than what is playing now, because see, we are going to start new mines which are auctioned mines, which are 1,000 rupees minimum costly than compared to the current mining cost. So this, if you're not controlling it in nice manner, in a more predictive manner, this will be a challenge for the viability of a cement plant. So let us, from the perspective of the usage and the perspective of understanding, this both aspects are very essential. So the land and mines, I think Aviva, I will tell that they should definitely work on that, and they should say and come with various software model how best we can explore this. Going forward, the fuel is another one very good aspect. And nowadays, when everybody wants to be carbon negative and net zero and sustainable model, then we have to go for a new era of or a new dimension for the AFR, which we say alternative fuel and material and management. Now, when we talk this, then the limit is 100 and more. So everybody is having some kind of percentage level. Some industries say I am at a 10% level, some say at a 50% level. But yes, this journey is helping them out in making them sustainable, making them profitable. So the journey of gray to green is very essential for every cement plant. And here also predictive tools are essential to understand in the heterogeneity of the green fuel, what best we can harvest from the world which is all around. So world is ready to give us the green fuel, which are going to replace the, in India particularly, the fuel called petcoke and coal, but in a manner which is more sustainable, can be handled by the predictive technology. So the predictive technology nowadays available, we can say that some technology, we can say PGNNA, some say that, the bulk analyzer, and some say that X-ray and XRD. So those technology are there, but we have to go extra mile here also. And Aviva has to see that how they are bringing a new model of green fuel predictive technology to help industry in understanding the quality aspect of fuel. so that at the source itself, we know what kind of CV, NCV, GCV is available, what kind of heavy metals available. So then it will be easy for the plant or a decision maker to accept or reject the material in the interest of the product. Ultimately, we are making cement. So cement should be viable. If you are taking unpredictable way and we are taking some material which is of a waste to a my industry when it is coming inside the material, then it would be a double cost for me to handle, and then the whole sustainable way will be questioned. So the fuel and limestone handling in a predictive way is the need of our and Aviva and the similar partners are requested to work on these lines. As our other panelists, I am hopeful that they will work, they will speak more on the machine part. Definitely, I have seen with my personal capacity that technologies are helping us in understanding the failure trend on trades much ahead, at least 180 days to 200 days before then what they are starting decaying and setting the alarms. That alarm may be of different nature. One alarm they can raise at immediate action, some alarm will be for a delayed action, but these alarms are very essential in establishing or arranging the spares or taking action in appropriate time, so that the whatever they are claiming 30% saving, definitely it is, I'm 100% sure this kind of technology is possible. I am sure the auto renting model what he is showing is feasible. I am believing this, and we at in my three good companies which I have worked, ACC, Ultratech, and Dalmia. So all three companies are definitely taking benefit, and across cement industries, they are going to take much advantage than this with this forum. So thank you, Ekta and team, for giving me opportunity to speak on that. Thank you. If any question on these lines, I'm ready to answer.
Thank you, Mr. Sinha. I think really good insights on what you basically talked about. And as you rightly said, when you talk about Aviva, and so I think Aviva has been in this. Aviva has been doing only one application for last 4 decades. It's been 40 years that they have been in this line of business, and the product has evolved to a lot of extent where whatever questions that you had, I think definitely we can address that particular thing, and we can connect with you on a one-on-one basis to basically understand more of it, and we can come out with the right kind of solution and the right kind of technology which can help you address this particular stuff. But definitely it's been 4 decades of work, and best part about Aviva is that they've only worked on one product for years, and I think the product has evolved. I think there are more than 450 OPC connectors and everything, and the product is really rock steady and been deployed in a lot of other cement plants, not only just in India, but outside India also. And the best part is the use cases that they have really bring in a lot of value to a lot of cement customers, and that really helps them in the long run. So thank you for your valuable input. I think Mr. Lakshmi, you had raised your hand. So anything that you had? Your voice, you're on mute, Mr. Lakshmi. You're on mute, Mr. Lakshmi.
Yes. Yeah. Now I am okay.
Yeah.
So basically, I raised my hand because I could not join in time. I joined it, but because of network issues over here where I am based on, this I could not continue. So that is for that. Sorry for that.
No
but
problem.
what I could hear and learn from it, that is very good. All those speakers, including experts, has spoken too much about this predictive, maintenance or whatever. But the basically very important point is the word predictive. Predictive especially is applied for everywhere. So in cement manufacturing industry, as Mr. Sinha has spoken, starts from mining up to the landing of the bag to the customer. But all those things are available, and most widely we had been using, and we are still continuing. Like Dalak system is available for the major gearbox condition monitoring, and that giving the inputs of even a small kind of thing which is related to like temperature or pressure. All those changes that Dalak is reporting to the customer, and customer or owner can take action accordingly. Now, my point will be specifically because basically I am the production man, and now as the operation head, I would like to add on certain points which are related to the refractory also, which I request Aviva to come with some a source of informative system which we can apply across the manufacturing unit, so that just like a cell scanner which now are being provided, or the filling scan monitoring system in the cyclones. Addition to that, which I will put on my point, that if any system is there so that we can get proper information of material filling inside the cooler, also the refractory condition inside the cooler, that may give us additional advantage of analysis to make the system strong and predictive for making the plan for maintenance. This is related to this. Other things are quite available in the system, and we are getting information. We are utilizing it, just like I told you, Dalag and all which some speakers spoken on the sensors and monitoring, which is available over the desktop or the system. This is all from my side. Anything we can ask. Thank you very much.
Thank you, Mr. Lakshmi. I think Rakesh, you have a question, right? You raised your hand.
Yeah, hi all. Very good afternoon to all. So myself is Rakesh. I have experience from last 10 years from cement industry. So my question is to Mr. Ramanathan. Am I audible to Mr. Ramanathan?
Yeah, you're audible.
Yes, sir. Yes.
Yeah, Ramanathan. This is my question is whether you are any technology, any system is there for noise monitoring, as the Vinay sir has told, for any bearing failure happened. Before that, it is having the 4 stages of failure. Step by step, it was the failure. So in the first part only, in first or second stage only, we can predict the failure analysis through the noise monitoring. Like whatever the sir has told, like in the initial stage, it is in the 120 dB, 1,27 dB, and after that it will be here for our year. So is there any technology with you for before early prediction of for noise monitoring? It will be help for current signature also for that.
So if you're asking me if we provide any sensors for the noise monitoring?
Not sensor.
Okay.
Not sensor. Based on the whatever sensor installed in a particular cement industry, based on that signals, is there any technology to convert from noise monitoring as well as from other technologies as per your experience?
See, we can actually use the sensors from the noise monitors. I'm not sure what is the sensor there, but we can use the data to build the mechanical model. So when we talk about predictive models, there could be multiple models. So one could be a process model. One could be a mechanical model. So in this case, if you are relating it to vibration and the noise monitoring of the bearing, we can build a mechanical model, mechanical predictive model, taking into account your sensor data. So
normally the sensors, what I seen, what I explained is normally the piezoelectric sensors will be there installed in the gearboxes or in the systems to capture vibration signals and all. So for in that, is it able to capture the noise, convert from the noisable signals, whatever the bearing has generating the noise? Is it doable kind of thing through the piezoelectric sensors?
I don't have an answer for this, sir. So I will have to probably understand your system a bit more with our technical team, and maybe we can see if we can, devise a solution.
Ramanathan, I will take up this one.
Sure,
actually,
sure.
What we use to do is that we use the normal our iPhone itself. It has got voice recording system. It is available, iPro. Okay, I used to take that data, just put that at the exact location where I wanted to do it. I mark it on X, on horizontal direction only I take. I collect the data, I download the data, it will get automatically recorded onto the iPhone. Then I used to have that voice at the same level itself. And once it is getting increased, it gives an input to me that, yes, my bearing noise is going now to it is increasing actually. Without greasing, it will naturally increase. When the bearing gets deteriorated more, it gets increased actually. Then I uses this MCSA, motor current signature analysis. Then naturally I can pick up. We also use this spectrum also, vibration spectrum. Then the two technologies will confer that there is problem, and once it is getting shifted into the audible range, by that time almost 5 to 6 months you can get an opportunity to get a stoppage. Yeah, you get, if it is kiln, you want to plan it actually, but for raw mill and other things we can plan it, and every week it gets shut down. So we plan it, and once we move it into the audible line, and when the frequency, the velocities goes up and then comes down, that is the time we used to take out the motor from the system and we replace the bearing. I think the problem is that we need to give a ultrasound sensor installed at one particular location, wire it to your system, so that your AI can do it much more analytical, because basically AI is much more intelligent. But of course, human being is more intelligent actually. But AI cannot miss the signal actually. Maybe my mood is out, I will be thinking, yes, motor gaya, bearing, it is gone off. But AI will not do like that. It will give a continuous input to us. So I think this can be wired up actually.
And it is, just to add to your point, sir. It is
actually
actually
for Vinay sir, I will add to your point, sir. Actually, I have done many case studies regarding the for any dry bearing means you will see that in noise monitoring some signals will be very high. If any the bearing is running with
the bearing, it will dampen.
Yes, yes. If you fill the grease means automatically the noise will be reduced.
Correct.
So I have did some many 2 to 3 case studies I have did in cement industry. So I'm a background of cement industry. So I'm looking that such kind of any online system is there for that to convert that our piezoelectric signal sensors. Anyway, all the gearboxes will be there. From those signals, if we convert from the through noise monitoring means it will be benefit for vibration as well as for noise monitoring also. Then we can predict, and then we cannot wait for up to the 4th stage. We can identify the faults or we can identify the predictions in early 1st stage, or maximum it will be the 2nd stage of the failures. If any bearing is any condition will be in a dry means, then only we can identify the things. So that's why I asked for any technologies for through the piezoelectric sensors is there.
So just to add to what Vinay sir and you have been asking, so we can also look at correlations between different signals. So it is not just one isolated signal. In this case, you're talking about one single isolated signal, right? So we can also correlate it to increase in temperature or increase of vibration when the lubrication actually goes down, right? So that is where an AI model will be more helpful. So it is not just one isolated signal that we are looking at, but we are creating a process signature of the asset by mixing in sensor inputs from different signals. So this can also be correlated when the temperature is going slightly higher for the bearing. So that can be.
No, sir. So some of the cases I have seen that even the bearing temperature is not rising, but the bearing has ceased immediately.
Okay.
I have seen in our trend, in our CCR trend, I have not at all seen the increase of the bearing trend. Okay. Suddenly it has gone. It is of mainly of kiln fan. I'm talking about. It is a very, if the kiln fan feed fan means we have to stop the kiln. So in such cases, I have seen some temperature is also not increasing. But in other support, we can see if any technology for noise means we can support with our vibration for noise and all, and it will be helpful for the to avoid the stoppages of the kiln.
Okay. So if the noise related, if the noise signals are available, we can actually use some correlation and bring in as a signal input in the software. So we cannot just actually process your noise or in terms of decibels that cannot be brought in directly into the software, but we can actually correlate to some relation and actually bring in as an input and see if that can be helped to build the signature of the models.
Yes. Ramanathan, you are correct. Actually, you need a correlation of different signals.
Exactly.
See, you can, for a bearing failure, you can have temperature, you can have vibration, you can have current signature.
Yes.
So there is a correlation going into it. Not one signal may not be very accurate on this, but definitely a correlation of all 3-4 signals will be helpful definitely in this way. Okay.
I think, yeah, we've really spent almost like 30-35 minutes on most of the question only. We have another 15 minutes, I think. So we'll move to the next discussion. How does real-time condition monitoring help in driving efficiency and improving the competitive advantage? So, Mr. Alam, you would like to basically take this particular thing and give your insights on that, on how real-time condition monitoring is helping driving efficiency and improving the competitive advantage. Do you feel that these kind of technologies, these kind of stuff can really improve the competitive advantage that you have in the market, and that helps you to gain a market share in your line of business also? So obviously, we'll start with Mr. Alam and then get some more people to talk on that.
Thank you for allowing me to speak on this issue. Actually, I'm really impressed to learn these things, and what I understood that this system is applicable for the latest plant. But for our case, our plant is almost 30 years old, where still DCS is not in operation, but PLC system is in operation. But we have another plant which is installed, 10 or 15 years old. So there is a DCS system. So on the basis of the DCS system, you can take all the sensors and take for incorporation in your system to get all the analysis. What I understood, the temperature or sound noise. From these 2 points, you are going to take all the analysis, and based on the analysis, you are going to take the report of the bearing conditions or rotating part conditions. That's what we understood. Thank you.
Okay. Mr. Chandra, you would like to basically add something on this particular point, or anyone else who would be keen to taking up this particular discussion forward? Or else we can move to the last thing. And what are the kind of predictive maintenance features which you would be looking at in your cement plant, which will help you improve your business? So what are the kind of features that you're looking out for, which will help you improve your business productivity and go to market? Mr. Mukherjee, you would like to take that? You're on mute, sir.
I think this, my more technical expert colleague should take this question. That will be more relevant for the panel.
No problem. It's open to everyone. So, yeah.
So basically, yeah, I would suggest that try to incorporate an ultrasound sensors wired into the AI, which will give you more inputs actually. Because basically, I try to use 2 inputs to get confirmed that the equipment is going to fail. I try to use that one. So if I get this one also into this one, ultrasound, does not have to wire it out on all the equipments. Wherever we found some abnormality, we will wire it and then we'll feed it into your system, so that you can have an AI system which will be analyzing this one and working out. Maybe you have to fine tune that program for some time, but it will give you an input. Then again, the second thing is DGA. Transformer has to be monitored, sir, because basically once we skip this one, we will land up in big mess, and that mess will be much more cost. It will have adverse effect on not only on the image of the company, it will be financially also, it will be very big, because of course there are always 2 transformers will be there which will be taking care of the plant operation. But anyone which can be having problem, it will result in major breakdown. So try to incorporate DGA data into the system, which will give you analysis of how the pepper condition is, how the oil condition is, what is the sparking which is happening inside, and PD partial discharge. That's also should be taken up, because all big motors, all big MV panels, which is dealing with 15 to 20 megawatts of power, will be using this partial discharge. Ultrasound also, again, there also you can use that. So try to incorporate this one, which will make the package complete rather than only the rotating equipment. Standstill equipments are much more reliable, and most probably the people try to avoid this. Transformers, they don't look at the height, the bucket lifters and the dynamic separators, which are main critical. Again, people try to use skip that because on jayega yaar, upar, who will go up to the top to find out. So all these inputs, if you get it into that system, your package will be complete actually. Only that much, sir.
Thank you, Mr. Vinay. Mr. Sinha, you had something to add?
Yeah. Thank you. See, actually, refractory failure is also to be dealt with predictive tools, and where you can do some betterment as far as the present technology is concerned. Like present technology of thermography is helping every cement industry in understanding the life and the remaining life. But there are some shadow zones, which this technology having some handicap things. So you have to think how those can be inbuilt so that the whole understanding about the life from zero to the whole length of the kiln can be understood, or even the other preheater and cooler side. Wherever some shadow zone where the current technology is handicapped, you have to think those lines. Like I will see that the below the roller area and the other area which is not being captured because of some baffles and some hindrances. So how to understand in extrapolation manner to get the prior signals of the life is is my expectation with Viva to deal with. Yeah, thank you.
Yeah, thank you, Mr. Sinha. I think Amit, you have a question.
Yes. Can you hear me?
Yeah, we can hear you.
Yeah, actually, I want to ask Ramanathan, how Aviva is contributing on predicting like cyclone jamming things and safety hazards related to cement industries. Is there any work Aviva is doing on predicting cyclone jamming things or any safety hazard issues?
Sir, okay. So cyclone, it doesn't have any, again, it doesn't have any rotating equipments, right? So this again is a sort of a potential use case for us because we don't have any references that I can actually tell you. So this is a sort of a potential area that we can look at. So right now, I don't have any cases that I can discuss with you for cyclone.
Okay. Thank you.
It was a pretty much exciting and engrossed discussion around some of the three topics that we talked about. I think my key takeaways from this particular roundtable, I would just summarize it and probably people can discuss and talk about it. I think one of the key takeaways which I feel today is technology-led change management. I think that is very, very important today. I think technology is all pervasive, and going ahead, the resiliency will only acquire new heights and meaning. Times are changing, but change is happening at an accelerated speed thanks to the technology. I think very, very important. If we do not keep pace with technology, we are going to lose out in the market space. We need to build a change management framework around organization's core principles. We need to have transparency across enterprise. When we are talking about deploying new technologies, new ideas, new thought processes, we need to have transparency across the enterprise, and it has to be a complete top-down approach. It has to be driven completely by the management, because change management is the most and the critical factor for a success of any organization in deploying any digital transformation application or anything. The clarity of thought, what exactly are we looking out from this particular application? Because when we are talking about an iPhone or anything, we buy an iPhone, we spend lakhs of rupees on buying an iPhone. At the end of the day, we just use the green and red button and just emails, and we don't utilize the entire feature and functionality of that particular thing. So it's very, very important that what is the thought process and the outcome that we are looking out for when we are deploying any technology. We need to always be communicating with the teams, because to create a successful deployment of any application, the collaboration and communication is to be very, very important. Build sensitivity to IT finance management by program teams. What are the critical success factors when we talk about tech lead change management? Engage thinkers from business teams, empower them to take the right and timely decision. identifying the right team, the mentor program teams through coaching sessions, introspect value objectives at regular intervals, because it is very, very important to introspect. Are we in the right direction? Is the decision right? Are we getting the right kind of output from the technology that we are doing? Secure the key members. We have to basically completely secure the key team members for the entire duration, set the goals, KRS and everything, and work towards it to ensure that we achieve the end objective, which is fulfillment of deploying the right kind of technology and getting the value out of it. So these are some of the key takeaways which I basically think through when we are basically discussing all this stuff. I again open the discussion to the panelists if they have any thought process on what I have said, and then we can basically end the session. So anything anyone would like to add as a closing remark, or anything that you would like to resonate with the thought process and the key takeaways which I have talked about? Do we agree to
Mr.
that?
Shreni, sir, I think we have a question from Paritosh Datta. He has requested if we can take his question.
Yeah, please. If there are any questions.
So Mr. Paritosh has a question to Aviva team. Like, please let me know whether you are using physics-based model or data-driven model for implementation. What is the model accuracy? So, Mr. Ramanathan, if you could answer this. It's in the chat box.
So we don't have physics-driven models, at least for this solution, sir. So these are all, the predictive models are all based on data patterns, pattern recognition models. So it's not the high fidelity models. If you are looking at mass and energy balance models, no, we don't do predictive models using those type of models. The model accuracy is again, I cannot associate a particular figure to it, but again, it depends on the consistency of data, right? So if we have a consistent data over a period of time, so the model again, the accuracy of the model or the prediction capability of the model increases with the number of sensors and the amount of data you are able to feed into the model. So that being said, we don't require past fault failure histories to basically to be available in the model to basically do a prediction. So what you're saying is, even if it's a good data, we can build a prediction model, and that can actually help you in predicting the failures based on the operational signature of the asset. So we don't require past failure data to actually build a predictive model. I hope I answered the question. So if there are any follow-up questions, you can please unmute and ask.
Yeah, there is one more question, Ramanathan. For the cyclone system, what I understand that the air volume and pressure volume are working through the entire area, and these sensors are going to be incorporated to the DCS, and we'll be able to come to know that cyclone jamming from the analysis of the DCS. So is that right? This question is from Mr. Alam.
Okay, so this is again, it depends on the quality of the feed that goes into the cyclone. So because and there are no rotating equipments and there are no rotating parts in the cyclone. So that becomes a sort of a future focus area, I would say, for the solution, because we don't have quality prediction models, right? So if we have the quality prediction models, that can really help in understanding what kind of material goes into the cyclone. If there is moisture, that can also be used to be built in the prediction model. But as a present scenario stands, we don't have quality prediction models in the solution that we have. Mainly the focus is always around the rotating machine. With that, yeah.
Mr. Alam, hope it answers your question.
Yes.
Thank you.
Thank you.
Yeah, Rakesh, I think you have one more question, I think.
Yeah, sir. Yeah, sir. Hi, Ramanathan. My question is to you.
Sure.
So, as you're talking about the prediction of your rotating equipments, because you are only concerned with rotating equipments. So my question is that for rotating mill of ball mill, do you have any future or any predictive calculation of wear rate in ball mills, like wear rate of ball mills as well as liners and grinding media? Because this is ball mill also is one kind of rotating equipment in cement industry. Right. So is there any? technology?
Liners, again, it is associated with the sound, I would say. So the sonic ear or we will have to take the sound into the sound, the inputs of the sound to basically understand the milling, the loading condition of the mill, or how the liners are actually, behaving. So the case that I was actually showing you in the presentation was mainly to do with the bearing, right? So which is again for the rotorantum use case. But again, we can actually explore how we can basically predict the failure of the liners, because that I understand that we'll have to take in the sound, the loading level of the mill, and also the sound as an input, ultrasound, sonic ear inputs to basically build the predictive model.
But Ramanathan, as you said, to build about the sonic, but you cannot install the sensor or sound for all the grinding media balls. You should have for any particular parameter or particular space you have to install the sensor, but it won't be the accurate, I think, because many balls are there in the grinding mill, and the sound will be some one ball to another, one ball to another. The differences will be there. So how you are going to predict in that way? Means any idea? I'm asking that. Just
no, we'll have to explore, sir. So again, see, the most obvious thing is to have a visual inspection. That is at this point, that is the only thing that I can comment on, because we have not built any predictive models to predict the life of the liner inside the mill. And as you rightly pointed outside, again, this is a very variable component, right? So you have different sizes of balls, and depending on the loading condition of the mill, the things could change. And depending on the raw material that you are grinding, the mill, the sound, sound could actually change. So I see that it is a very complex model that we can build. We'll have to build, but we can explore, sir. We have not built anything there to basically show you use case.
Okay. So for thermal imaging, is there anything for your technology is there for thermal? Because this kind of, because for thermal imaging, we are monitoring on the rotating equipments, as well as kindly say, Vinay sir kindly said that in the electrical panel also we are contributing we are avoiding the breakdowns or stoppages. So for normally cement industry is doing practically in offline mode. Means some external person will come and they will do before shutdown and after shutdown, they will monitor, and then they will give, if any problematic is there, they will contribute in the shutdown. So for those things, anything technology is there for thermal imaging?
So thermal imaging, can you explain that use case that you're looking at, sir? So thermal imaging for which asset are you looking at?
Means for rotating equipment as well as for electrical panels, monitoring of electrical panels. Like Vinay sir told, HP panels and LP panels, for all type of panels. Because this rolls very critical stage when the for fans motor, because I have seen many after stoppage of kiln, some 1 month shutdown. Later when we start, some 15 days after 15 days we have faced of electrical panel short problems. So is there anything of technology?
No, for panels we don't have any predictive models in the present case. So, but we can surely explore. See if we can build such models for. I think transformers is again one of the inputs that Vinay sir is giving. So we can see, these two can actually be covered.
Rakesh, just to add to what you said, any predictive models, that predictive models need to be understood, studied, and then we need to build. There are no ready predictive models which are available, which just out of the box you can just connect and you will start getting things. So predictive models, the Aviva solution, they have certain output, certain data that you can get from the Aviva dashboards and everything. But when you talk about the predictive models, these are customized models which need to be built based on the customer's understanding of the business and what is the kind of output they're looking out for from the model. And based on that, they are purely customized for that specific requirement of customers. So predictive maintenance or predictive algorithms are built based on the customer requirements. They are not out of the box, which you can connect and you can start getting output from that particular stuff. Certain use cases might be there, but not for everything.
No, just to speed up the enterprise level deployment, what we can also do is once we actually build a predictive model for a particular asset, So that can be used as a template to roll out to other assets. So that can be done. So that will help in faster deployment across similar assets in your industry. So that is something that the solution can support. But yes, it is a purely customized solution, that we'll have to build for your particular asset.
I think we've really overshot by 10 minutes, but I think the discussions are still going on. I think I can definitely say that it was a pretty interesting and completely people were glued to having this interactive session. And I was really pleased to see that there was not a monologue. It was a dialogue where there were a lot of questions which were put across to the Aviva team, a lot of insight from industry stalwarts giving their experiences and how they have been deploying the solutions, how they have been working in this industry and getting the right benefits out of it. So I would really appreciate, thank you everyone for taking out time today, attending this particular roundtable conference organized by Analytics along with eCubix and Aviva team. We really appreciate everyone taking out time on a Friday evening, attending this particular thing and having an interactive session. Thank you, Ekta and your team. Thank you, Ramanathan. Thank you, Aviva team, for having taken out time and attending this particular roundtable. Really appreciate everyone for joining in.
Thank you.
Yes.
Thank you, everyone.
Thank you,
Thank you so
Shanik.
much.
Have a nice day.
Thank you. Bye-bye.
Yeah, I would just like to
Thanks for
conclude
Rajas.
that. I would just like to conclude that again, what Shrenik said, that on behalf of VCS and Aviva, we would like to thank all our thought leaders, all the speakers on the roundtable for taking out your time Friday noon and being with us. Of course, the lovely audience to make it so engaging by your questions. It was really interactive session. I could see that. Then I would be sharing the video of the entire session with each one of you, the speakers and the attendees. And we would love to reconnect you with the VCS team, for their wonderful solutions that we spoke about. So on this closing note, thank you once again and have a lovely weekend ahead. And please take care of yourself. Stay safe, everyone.
Thank you.
Bye.
Take care, everyone. Have a great weekend.
Bye-bye.
Thank you.
Yeah, thank you.
Bye. Bye.
Thank you. Thank you.